Hey, Algebra 2, welcome back from fall break. I hope you had the chance to rest up, get that well-deserved rest from a crazy 9 weeks for the first semester. And I hope you're ready to just kind of push through these last 9 weeks so we can move on to greener pastures. Um, we're gonna go ahead and kick things off for the second semester. I mean, we already kind of are in the second semester, but sorry, the second quarter, which is the second semester of Algebra 2. You know what I'm talking about with all the weird stuff going on. Let's go ahead and keep on working in chapter 8 with 8.6, solve rational equations. The rest of this week we're going to spend looking at rational functions. So this will be the last kind of preparation for looking at rational functions. Okay, we're going to finish things off with 8.3. We're going to go back a little bit and we're going to spend a few days there. Okay, so our objectives are to find the solutions to rational equation. So there could be solution or solutions. There might be multiple answers. And we want to identify when a solution to a rational equation is extraneous. Okay, so here's a new word that we'll talk about more when we get there. Extraneous. Okay, that's a new vocab term, but we'll get there. Okay, so let's just kind of dive in. Let's just start with some examples. Solve. Identify any values that x cannot be and check your solutions. Okay, so this is kind of out of order. We actually want to do this first. Identify any values that x cannot be, and let's talk about like why. Because normally we're used to just solving for what x is, not what it isn't. Like we don't really care about that. Um, but when we think about rational equations, we do. And why? Well, first of all, why is this a rational equation? It's because we got rational expressions and an equal sign. That's pretty much the just all there is to it. That's why it's a rational equation. We got fractions with variables both in the numerator and denominator, but at least in the denominator. And we have an equal sign. So there's the equation part, and then the fraction part takes care of the rational aspect, right? So what does this mean by values that x cannot be? Well, remember, what is one thing, what are some two things right now that kind of breaks when we talk about real numbers? Well, first of all, we can't take square roots of negatives. We can, but we end up in the complex numbers. But here we're dealing with real numbers, right? The other thing that breaks in math is dividing by 0. Okay, and now that we've introduced rational equations, rational expressions, we run into that off chance that we can divide by, or that we will end up dividing by 0, which is something we don't want to do. Okay, so that is kind of where this whole what are values that x can't be, that's where that comes in, because we want to look at this and say, well, if I think of this first fraction, if x equals 0, then I'm going to have a division by 0 here, and that I don't want that. So I'm going to start by saying, well, before I find my answer, I want to make sure first I don't include 0. So in the off chance that I do get x equals 0 as an answer, I don't want that. I don't want to include that. I want to throw it away. Okay. And then what's another thing that can make a division by 0? Well, 0 is the only thing that'll make this one a division by 0. What about this other rational expression? If I plug in 0, I get -7. So 0 is not an issue here. But the number that is an issue here is 7. So I can't have x be 0 or 7 because then I run into that issue of division by 0. Okay, so whenever we solve rational equations, you always want to start off by just figuring out what are the answers that you can't have. That way, when you get answers, if by any chance you get x equals 7 as one of your answers, you have to throw it away. All right, and we'll talk about that more in example 2, but just kind of getting ourselves used to doing that at the beginning of all these problems. Okay, let's actually solve this now. So what are we going to do to solve this? Well, I need to solve for x. It's not going to do me any good to have it in the denominator. I want these x's in the numerator. Okay, so really what I want to do is I want to multiply, let's say this will start on this side, multiply both sides by 5x. Okay, what happens when we do that? Well, on this side they cancel, they simplify out, and I'm left with 3 is equal to 2 times 5x, right? Because it's technically 5x over 1. 2 times 5x over x minus 7. And I'm almost there. I don't want this x in this denominator, so now I multiply both sides by x minus 7. Okay, so now I have 3 times x minus 7 equals 2 times 5x. Okay, now you're probably seeing this and you're like, Mr. G, there's a faster way. Why can't I just cross multiply? You can, right? So, maybe some people haven't seen this before, but if you have, you're probably sitting here like, let's just cross multiply. Let's not waste our time doing it in 2 steps. Let's just do it in 1. Now, for those who haven't seen it, cross multiplication is just a shortcut of this, right? If I start off with just 3 over 5x equals 2 over x minus 7, when I have the equal sign, and when I just have one fraction on each side, then I can just say, oh, well, let me cross multiply. Let me do 3 times x minus 7 and 2 times 5x and get 3x minus 7 equals 2 times 5x. Okay, so that is, it's a shortcut, but you need to understand that cross multiplication, so cross multiplication only when one fraction on each side. Okay, because otherwise if you have multiple, then that's not going to work. It's not going to come out nicely. Okay, so write this down, pause the video because I'm going to erase it so I can get some room to do the work. But write this down, that way you're not cross multiplying in every single one of these, because in our second example, we're going to see some problems where cross multiplication doesn't really work. Okay, let's keep going. So then for this one, now that we have x's in our numerator, we can just go ahead and solve for x. Let's get x on the same side and everything else on the other. So first things first, let's go ahead and clean this up. I can distribute this 3. So I get 3x minus 21 is equal to 2 times 5 is 10x. Okay, now we just have to get x by itself. My x is already over here kind of isolated from that number, so let's subtract this 3x over. You could really do it either way, but if you subtract the 10x over, you'll have to then add 21 over. It's going to be the same no matter what, so do it whichever way makes more sense to you. Minus 21 equals 7x. Now I just got to divide both sides by 7. We get x is equal to negative 21 divided by 7 is negative 3. Okay, so we only had one solution here. All right, is that okay with the answers we had up here, or the restrictions? Okay, we'll refer to this as restrictions. Does this okay with the restrictions up here? Yes, because we didn't get 0 or 7. So we don't have to worry about throwing the negative 3 away. All right, so our answer is negative 3. Let's check our work. We'll only do this once just to kind of show you how you're supposed to check your work. But if you're ever in any doubt, like, oh, I don't know if that's the right answer, remember, you can always check your work because you can just plug it back in. So let's plug in negative 3. We have 3 over 5 times negative 3. Hopefully is equal to 2 over negative 3 minus 7. So 3 over 5, this is going to be 3 over negative 15. Hopefully is equal to 2 over negative 10. If I simplify this side, I can divide both sides by 3. That's going to be a negative 1/5. I can divide both sides over here by 2, and that's also going to be a negative 1/5. So yes, this is true. Okay, so our answer is negative 3. Okay, we're not going to spend time checking every single answer, but just know that if you're ever working on these kinds of problems, you can always check your work by plugging it back in. All right, let's do another one. Okay, here's another case where we can just directly cross multiply because we got one fraction on each side. So let's do it. So negative 4 times x minus 3, and then x plus 3 times 5. So you get negative 4 times x minus 3 is equal to 5 times x plus 3. Okay, so then we do some distribution. We get negative 4x plus 12 is equal to 5x plus 15. And now we just solve for x. So really you could do this either way. I'm going to add over this 4x, and then I'm going to subtract over the 15. Okay, so subtract 15 here, and then add 4x here. Okay, I'm just doing it all in one step. If you yourself need to do this in 2 steps, please go ahead and do so. All right, so over here, this simplifies out to 0. 12 minus 15, that's negative 3. Yes. Yes, just had to make sure. Equals 5 plus 4, that's 9x. 15 minus 15 is 0. So then all I have to do is now divide by 9 on both sides. We get x is equal to negative 1/3. Cool. Okay, something we forgot to do at the very beginning is see what x can't be. So what will make this division, what will make this into division by 0 if I had a negative 3. So I definitely know that x should not be negative 3. But then if I look at the other denominator, it should also not be positive 3, because positive 3 will make this denominator 0. Okay, so these are the values that x should not be. Is that okay with, is our solution okay with these restrictions? Yes. Okay, because it's not negative 3 or positive 3, so we don't have to stress about it. Awesome. Let's do another, and then we'll go ahead and look at a different type in the second part of this lesson. Okay, so we got 1 over 2x plus 5 is equal to 11x plus 8. Okay, and I have to make this statement really quick because I saw it in your guys' midterm. We can't simplify these out. That's a no. Don't do this. Okay, this is not something you want to do because a lot of you guys simplified those x's out on your midterm. You had something like x plus 5 over x plus 9, and you said that was equal to 5 over 9. No, that's not true. Plug something in for x. Let's say, for example, x is equal to 1. If I plug in 1, I get 1 plus 5 over 1 plus 9. That's 6 over 10, which is 3 over 5, because I can divide both of these by 2. Is 3 over 5 equal to 5 over 9? No, right? This would be true if x was equal to 0, but that's only one value of x. So just don't walk into that pitfall, okay? Don't cross those x's out. They do not want to be crossed out like that. Okay, so let me clean this up. X. Okay, let's go ahead and do that again. So then let's cross multiply. So 1 times 11x plus 8, x times 2x plus 5. It doesn't really matter what side of the equal sign they go. I could very well just put, x times 2x plus 5 is equal to just 11x plus 8. It doesn't matter what side of the equal sign you put them on. Okay, on the left, let's go ahead and distribute. We have 2x squared plus 5x is equal to 11x plus 8. Oh, look, it's a quadratic equation. You are experts at this by now, hopefully. Let's go ahead and subtract everything onto the left. So minus 11x minus 8 minus 11x over here, because that's not a like term. Just getting ahead of myself. Actually, it doesn't matter. Just make sure you subtract them correctly. Okay. So on the left, on the right-hand side, they all simplify each other out. Over here, these are not like terms. 5x minus 11x, I get 2x squared. 5 minus 11, that's negative 6x. 0 minus 8, that's negative 8. Okay, and now on the right-hand side, we have equals 0. We got our good old equals 0 on the right, so let's see if we can factor this. Now, if you remember kind of what I said in class the other day, now that we're at this point in Algebra 2, you guys, if I ask you to solve a quadratic, you can either just straight on go ahead and do quadratic formula immediately, or you can go ahead and factor if it's possible, whatever is easiest for you. I kind of find factoring to be a little faster just because I've had years of experience, so I like to say I'm pretty decent at factoring. But if you don't kind of agree with that statement, then by all means, just plug it straight into your good old friend, the quadratic formula. Okay, so I can factor out a 2. We're left with x squared minus 3x minus 4 is equal to 0. And then I can just divide this 2 out, so I can just ignore it. So I have x squared minus 3x minus 4 is equal to 0. And this factors to, what does that factor to? That's x minus 4, x plus 1 equals to 0. So then if I solve for values of x, I get x is equal to negative 1 and positive 4. Okay. So those are my solutions. Let's backtrack. I keep forgetting to do this. Let's backtrack and see what values of x we're not allowed to have. So what makes this first one 0? If we can't see it immediately, we'll, set it equal to 0 to find out. So we subtract 5. We get 2x is equal to -5. And then x is equal to -5 halves. Actually, though, these would be non-equals, right? Because we don't want x to be that. So we know x can't be -5 halves, and then 11x plus 8, we don't want that to be 0 either. We get 11x equals -8. So x cannot be -8 over 11. So these are our two values that x can't be. Do they agree? Yes, we're good. We're golden. Okay. So hopefully that sounds good to you guys. Meet me in the next part of this video to talk about extraneous solutions. Okay, see you there in a few seconds.